Welcome to develop high-performance sites and modern apps with JavaScript and HTML. I see some familiar faces here. For those of you who may not know me, my name is Doris Chen. I'm a developer evangelist at Microsoft. I have been with Microsoft for about 3 years. So I'm a kind of web person. I'm always on web. So before Microsoft, I actually was working with Java community. I was the Java evangelist at Sun for about 10 years. You know, I'm working with a lot of web developers, open source developers as well. So let me actually give you some of the links. I already posted the presentation for today onto my blog. So if you want to take a look at the presentation, it is on my blog, the very first one. I usually don't remember my blog URL, so I just do a search. It's if you type in my first name, Doris, D-O-R-I-S, space, MSDN, for letter, MSDN. Usually the first link will be my blog, so I should be able to see my blog. Also, if you would love to talk to me on Twitter, I have a Twitter. It's Doris T. Chen. Notice there's a T. So people complain, say I never reply their Twitter. But if you put a Doris Chen, I'm not going to receive it, right? So put a Doris T. Chen, okay? My Microsoft email, in case you have some feedback and you have more follow-up questions about this talk, feel free to email me. Now, there's something which we sort of like just started doing it. It's what we call office hours. So it sounds like still at a school, isn't it? How many students we have here? Okay, a couple. So we learned from school. What we find out is a lot of times we have a big conference like this, and you attend my sessions, you ask some questions, but sometimes you may still have follow-up questions. You'd like to get a little like a one-on-one kind of answer. So I do have an office hour, so you could assign up a slot with me, so I could help you further. My main focus these days are helping you to write apps by using HTML, JavaScript. All right, so you could actually, if you're interested in writing apps, or if you have some questions about that, you want to know how to get started with, let me know. This is my allhours.org/Doris Chen. That's my office hours. So before the industry, I spent a lot of years in research in school, try to get my degree. I actually focus on computer engineering, specialize in medical informatics. So if people interested in medical informatics, let me know. Okay, so let's, because it's only a 15 minutes talk, so let's actually get into the real part. So I'm going to actually share with you really quickly the general best practice for JavaScript. And then we're going to actually use a casual game. I will show you how I'm going to actually apply different principles to make it running faster. What are things you need to watch out in your code, and what are the things you could leverage our modern JavaScript engines, right? Because the idea here is, you know, there's a lot of performance talks everywhere, right? And you probably, this is an older topic, you know, people seem like, you know, more than 10 years ago, we started to do the web performance, right? But I think the really value for this talk is try to show you, you know, how you could apply the same principle to the website as well as to modern apps. And also, because we have all the modern browsers, hence we have all the modern engines, modern JavaScript engines, right? So what are the things we still need to watch out? What are the things we could leverage to make your app runs a lot faster and better? So this will be the main focus for this talk. Okay, so before I get started with, how many of you are JavaScript developers? It's very full house. Okay, very good. So we're going to actually show a lot of code. Okay, so you're probably wondering, how I'm going to, you know, I'm a web developer, I would assume, right? So how I'm going to actually leverage my skill set and maybe even convert my web content into modern apps like a Windows 8 app. You know, what I need to do, right? So very quickly, let's actually just go over this sort of like what I call the architecture of Windows 8. So there's a lot of languages will be support to use to develop Windows application. However, what we want to focus on will be the HTML JavaScript, right? So this part of the green area is what we do every day. We're developers. We develop web content running on a browser, whether it's IE, Chrome, Firefox, or cross-browser. That's what we do, right? So this part is still business as usual. No change, right? You still write your web application using the JavaScript, HTML, maybe CSS. Now, the part which is new for modern apps is this what we call, I usually call it's more like a native HTML5 JavaScript apps. So the idea here is on Windows 8, we're sharing the same JavaScript engine. So if you could actually develop some app and running seamlessly on IE 10 and above, then you have very good chance to run it in the Windows, because basically you could simply copy and paste your JavaScript or web content into Windows 8 platform, so that you could actually leverage all your web skill, leverage even your web content to make it a modern app, a Windows 8 app. So that's the concept. Obviously, that's not a focus for this talk, but I just want to show you everything you do, the best practice we're going to talk about, the performance tips we're going to share with you is also apply for Windows apps as well, right? So because they're really underneath that share the same JavaScript engine. So it is the same engine we're talking about. Right, so if you want more information towards the end of the resource, I will show you how to get started with. All right, so let's actually start with, I try to, I found all the performance tips, right, from Steve Souders, all the books, all the best practice for JavaScript. Some of them are still really useful. I'm going to share with you a few of them. For example, you could, for safe dynamic content, still use inner HTML to create your DOM, even though this is an old technique, but it still applies. It's still good to use. The other thing is, how many of you, realize you should always keep the CSS at the top of the page? Anybody? Okay, very good. So this is really still very important for modern apps and the modern, application running on the browsers. Because if you don't have your CSS, basically you're going to see the page seem like it never loaded. So the next question that relate to that is how tolerant you are. 5 years ago, I gave a similar talk on the performance. At that time, people tell me 3 seconds is all they could wait. So I would ask you today, how many seconds or milliseconds you're willing to wait? Anybody? 0.5 second? 500 milliseconds, that's about right. Even though we don't really have a number, but really nowadays, people's tolerance is getting worse and worse. So they need a faster site. So we do talk about milliseconds. That is correct. So you really have to make sure your CSS starts on the very top so that you will be able to see the web content immediately, right? The other thing is try not to do a lot of inline JavaScript and CSS. This is probably not something you should do. And then you should not pass your JSON by your own utility. You should always use a JSON utility, because we all love JSON. One of the reasons is because it has a really cool utility for us to use, right? And then if you want more tips, then you could go to this session. It's called 50 performance tricks to make your HTML5 app running faster. There's 50 tips there. So you could go to this URL and take a look at the presentation. Okay, so I guess enough of the general best practice. Let's actually get into the casual game we have. Okay, so what we have is, let me actually just show you this game. So again, it's a web application. And it's really a single player kind of application. And let me actually just open up a few files. Okay, so let's run it. All right, so didn't hear the music. I don't know what's going on. Let me actually unplug it. So you could hear something. So basically it's a high five kind of game, right? So we could actually, you click on one of the person there, and it's going to rotate like from maybe this angle to the 90 degree. And then if I hit my neighbor as a high five, then my neighbor is going to rotate, and then until the neighbor finish the rotating for everybody, right? So this is a fixed matrix, And then let's actually make it a little, more matrix. It's basically every single person there represents an object in this matrix. All right. So what I'm doing here is I'm actually let me actually do. Oh, I'm so sorry. No wonder I was like, you guys are really quiet. All right. Let's see. Yeah, forgot to change it to the slide mode. Okay. So this is the game I'm talking about. Let's actually get it back a little bit. It's a high five game, right? I click on any of them, they rotate, causing the neighbor to rotate until they finish the loop. And then I create a matrix, make multiple persons could play this game, right? So getting a little crowded, And then what else would you see is, you see this is frames per second. People usually use that to measure the web performance nowadays. So what I did is I actually created a benchmark, and then using the benchmark so that I know a known state to start with. And then later on, when I play the game, I know exactly the number of high fives we're going to get and all those things. I'm using that. So there's one of, performance. If you think about the whole idea of performance is because you think your performance of your app is not good enough. But who is the one to define your performance is not good enough? Is that you, by I, looking at I think this performance is slow? Or is your customer give you the request? Or you have a performance test? So everybody should have some kind of performance criteria in mind when they do the performance tuning. Because otherwise, what kind of performance you're talking about, right? You really have to have a criteria to say you pass the test or fail the test. So in this case, you probably want to measure. One of the parameters we actually going to measure is frames per second. So I'm using Windows 8.1. The most current browser is called IE 11. And how many of you on IE browser, if you want to take a look at the JavaScript, debug it, and also take a look at what we call UI response, there's a magic button to hit. That button is called? F12. Very good. You deserve a t-shirt. Okay, make sure you get a t-shirt from me. So F12 too is all you do, right? So this is exactly what I have. I have a F12 too. So this will be, you probably use some other browsers. And then what we talk about the best practice, all the coding practice, will apply for other browsers as well. But because, IE will be a natural choice for me to use, so I'm just showing you use IE 12. And then you could see all the DOM Explorer, what's inside there. You could actually take a look at the debugger, whenever you want to do. This is what we're going to talk about. It's called the network. I'm sorry, this is like a fiddler, like checking the HTTP request, the response, all those things. And then your response, we're going to actually spend some time talk about that. You could also do the profiling to measure which method takes the most of time or which library method takes the most of the time. You could even take a memory snapshots. So you understand which one causing too much bottlenecks or which one takes too much memory there. So this is sort of like just a generic. You want to take a look at what's really going on. This give you some display layout. Work really well for any of the tablet. Okay, so we go to the UI response, and let's make it a little smaller so you can see. And then if I start profiling, and what you will see here is you will see some performance, right? And you will see every time it started from sort of 0 to about 5,000. And if you could see that's overlapping a little bit, there's a FPS here. It's kind of like a 30, 50, 60. Okay, I think enough data. So let's stop it and take a look at the detail. So it's analyzing all the data I just took. And like I said, one of the performance meter is frames per second, right? So what we see here is this is a frames per second. And you obviously the ideal case is every single rendering, every single move on the screen will be 60 frames per second, right? So you will actually should see something very close to 60. But when you look at this curve, you probably see there's a lot of 30s, even 20s. There's a little gap here. So usually what I do is I will actually take a look of a particular gap, right? To see say if I'm interested in this gap, I could really take a look. So it will actually give you the little time frame on that, and it will give you all the data. For example, I could even take a look at the duration. So you could see the green area is the time it will do the starring. The yellow area is a garbage collection time. The scripting time is represented by orange. And then so is some other things, depends. In this case, I don't have the image decoding or loading, but if you do have that, it will also show in this diagram. So you will be able to use the frameworks per second to do visually how you see your application, as well as dig into a little more detail to see which part seems to give you the most like a problem in the performance, right? So we do see something like 54 millisecond, 36. We see this garbage collection, it takes about 24 milliseconds, right? So obviously these are the data just for one of the test case. Your mileage might be different, but that tells you something, right? You sort of figure out what is in that little dip, what's really going on when you have very low frames per second. Okay, so let's actually continue from there. So what we have here is, let me go back to the game a little bit, right? So we have a matrix of multiple players, bunch of people, right? Each player represents an object on the matrix. And then each player has a set of directions, 4 directions, right? This and that, 4. And then each touch, you select a player, you touch that, it will generate a list of neighbors to rotate, right? And then you will rotate until all the neighbors finish that loop. That's what we have in the neighborhood. So this is a high five game. Now, what it involves is it involves using the arrays in this code, involves object and its properties, involves bunch of number, mass, right? Involves animation loop. You see there's a little animation when you rotate all those things. Involves a lot of memory allocations. Think about so many objects have to allocate into this matrix, right? So, as we sort of like showing you from using the F12 tool, the UI responsiveness, right? You already see the visual throughput, right? Which we use in frames per second is not really that great yet. So we want to look into a little more detail what impact those visual throughput or what impact your frames per second data. So obviously, every browser, every engine has slightly different kind of what we call subsystems. But then this is basically from IE. And if you look at that, I'm not going to go over the detail, but basically every JavaScript engine all have that. So you're looking at the networking, right? How long does it take getting the request? The HTTP, CSS, JavaScript, all those parsing, as well as the time to create a DOM tree, to create a dynamic DOM tree, as well as to interpret those DOM into some particular dimension or some size, so you could do the layout, and then also including the time to put a layout, translate into the pixels, and finally render onto the page. So this is what we call a few, like, I think about 11 subsystems. Now, just briefly go over that because you don't really have to, know each exactly what's going on because the tool will actually tell you with different code, different color of the coding to tell you if it's a garbage collection takes that time, or if it's JavaScript to take the parsing time, or if it's a layout, if it's a rendering, and so on. Now, what I want you to pay attention is looking at UI thread. No matter what, it is a single thread, isn't it? So for that single thread, you may have different multiple paint, but if you're looking at each of those paint, the highest we could get, or the best performance we could get, is 60 frames per second. So if you do the math, divided by 60 frames per second, you will see each paint should be finished less than 16.67 milliseconds. If it's more than that, then you start to see your frames per second is less than 60, which is not that ideal. Right? If you do like a 30, if you do 1 divided by 30, you look at yours is actually maybe 30 milliseconds. So how are we going to actually keep our code of each of the subsystem, all those subsystems running less than 16 milliseconds? Remember the garbage collection for the previous one already take 24 milliseconds. So that tells you it's obvious not going to reach that ideal number, 16 milliseconds. So this is our job. Try to take a look at the code to see if we could minimize that. So having said that, the tools, if you want to look further, one is called F12 UI responsiveness tool. It's part of the IE. If you download IE 11, you will have that. It's part of that. The other one is I actually use a lot when I see the bottleneck. I want more detail in terms of CPU utilization, threading, garbage collection, all those things. I use Windows Performance Toolkit, which is also part of the Windows, and you could use that as well. And obviously, there are so many other tools available you will be able to look into. So first, let's look at a garbage collection. And I do see this is what I have. I have the garbage collection. It seemed like it happened, very frequently from this diagram. And when I see that, I know this is probably not a good sign, because you're not supposed to see garbage collection happen so frequently, right? So our first principle we want to talk about is memory usage, stay lean. Okay, this will be our first thing to look into. Now, whenever you make a new, with JavaScript, you create a new object. You put new, right? Or you implicitly doing some memory allocations. It's all going to accumulate to the GC memory allocation. Until how many of you actually never heard about garbage collection? Okay, everybody, good. So until the garbage collection is full, then it's going to clean up. Now, every cleanup, basically, it's going to slow down the performance, because it doesn't matter how fancy the garbage collection is, even though we say modern JavaScript engine is very good, but then still garbage collection is going to take some time to clean up, right? So it will always cause a pause. It could take a few milliseconds. From a previous data, we see something, it's like 24 milliseconds, right? So it does, all the garbage collection pause is going to slow down your performance. So that's why we need to take a look, how we could make it better. So let's look at the code. What I have here is a very simple, I actually put in one big like a JavaScript file. It's about 479 lines of code for that particular high-five game. And the first thing I look at is a keyword, new, right? Like I said, new is the one you do the memory allocation. So let's actually take a look. Some of them looks pretty good. It's create an array, create a matrix, create prayers for that, nothing suspicious. So let's look down a little bit. And this is all the new is try to create each prayer. There are two prayers. One is called Judy, one is called Mir. And these are just creating each prayers with a matrix. So I use array here. So it looks pretty okay. This is the one I'm trying to fill this particular game board by use what I call the benchmark. So I do fill each matrix using different kind of like 4 directions to create that. So nothing suspicious here as well. Now, this is the thing I start to look into and feel that might be something I could do it better. Now, so here, I'm actually using what we call object pool. How many of you heard about object pool? Okay, so object pool is very commonly used in JavaScript development. The idea here is you will be able to recycle the objects inside your pool so that you don't create all the new objects again. So for a matrix like this with all the objects, we highly recommend you to use object pool. So in this case, we're using object pool to create different prayers. And let's go down a little bit. And here, what I do is every time I touch some another prayer, it's going to rotate, right? So here, what I do here is I'm introducing another position called east. Like for example, if it's a northeast, then it's rotated, become east-south. So basically, in addition to for all 4 direction, north, south, east, west, I'm introducing another direction called east-south, and then so on. So every time I touch that causing the prayer to rotate, I'm using east, south, southwest, blah, blah, the other 4 directions into it, right? So obviously, we could think about, is it the best way to do, right? Do I need to introduce another new properties into this particular object, right? So the other thing, this is not really catching the attention, is whenever, when I hit that person, it's going to rotate. When I really do the rotate, what I'm doing here is I'm creating another new object for each that node just about to rotate. Now, this is definitely, there would be something wrong with that, because we're using an object pool, right? The idea of using object pool is try to fill in all the existing nodes already there as much as possible, to recycle as much as possible, instead of creating old new objects all the time. So this is definitely one of the area we should not do. So this is basically checking this north, east, east, south, what I should do. So I'm creating a bunch of new objects here. Okay, so time to fix it. So what I do is first of all, I make the things a lot easier. So in this rotate fast method, I don't introduce additional northeast, southeast. I'm still playing with north and south, because if you look at the rotation, right, the northeast and the southeast, no matter what, the middle one is always east, right? It's only the north and the south are changing. So in that case, I don't need to really invent another direction to put it into the property. I could just keep it as north or south. So in this case, it depends on the direction. I'm assigning north to 0 and south to 1, or east, west, and so on. So this really saves me the property. I don't create additional property. So that's one thing. The other thing I create is I'm really, remember the previous routine when we actually do the commit, we actually using a lot of new object. Every time they rotate, we create another new object for that. In this case, we don't. We actually just recycle all the node there, signing up, right? Assigning the existing player either to 0 or 1 to identify this is a new position for rotate. So after we do that, let's take a look at the performance. So I need to actually just change some of the code here, just to save some time. So I'm going to change this to called commit rotation faster, and then this one's called commit fast. All right. So let's save it, and let's take a look. Let me actually kill my previous one. It's always good to clean up your browser and even cache. Make sure you don't have any old cache inside your browser. For performance tests, it's extremely important. Okay, so let's actually change it for the benchmark. Start playing. Now we see quite a bunch of 40s, right? We see some 60, 50, 40s. Well, we still see some 30s, but it's getting better. We don't see a bunch of 30s or even 20s. We see like a bunch of 40, 50s is getting better, right? So that's a good sign. Like it. Okay, so let's continue with some other things we could look into. Now, anybody want to guess what kind of result I get in terms of performance gain? So what we see here is after we fix all the new objects into the object pool, we reduce the garbage collection by 1/3. And hence, we actually also improve the raw JavaScript performance by 3 times. So we actually show you some of the data with a graph. You could take a close look. I'll post a slide. You could take a look. In all the code, I will show you where to get all the code before and after. You will see that. All right? Sounds good? Okay, so let's move on to our next principle. Before we do that, we just wrap up. Best practice for stay lean. Avoid unnecessary object creation, like what we did, a bunch of new objects. Use object pools whenever possible, especially work with a large amount of objects. Beware of your allocator pattern. For example, how many of you set a bunch of closure in your event handlers? Did you do that? Did you purposely try to clean up those closure? Because if you don't, it's going to be stay there forever. It's going to take a lot of memory. One thing. The other thing is try not to create too much dynamic DOM tree. If you can, with some easy ways to do that, don't always create a bunch of dynamic ones. Make sure you don't allocate a lot of objects implicitly in the engine. You feel it's just an implicit allocation, but it's also going to take up a lot of memory, right? Even though you think it's not explicitly, but implicitly also takes a lot of memory. Remember that. Okay, second principle, use fast objects and the manipulations. So let's take a look. Now, this is something, I think not everybody kind of aware of that. So for any JavaScript engine, doesn't matter which browser you use. If you have a particular one called P1, has 2 properties, north and south, like this, the very first thing in the compiler, what they do is they always allocate a base type like this. And then what they do is when you have north equals to 1, you have a property assigned to 1, then we allocate another object called north equal to 1. And then you have another piece which is south, defining south equal to 0, right? Then you actually have another piece called south to 0. So here you have your two properties, north and the south, with an object called P1. Now let's take a look at another object. It's called P2. It has exactly same properties, north and the south. The only difference here is the south property is actually the order of the property changes. This is north-south, this is south-north, right? So I'm doing exactly same allocation in the memory itself. Now, can somebody tell me at least P1 and P2, these two object type are the same? Probably you would guess by the way I ask you, right? So, yes, these are not the same object type, even though that particular object has the exactly same property, has north and south. But because the order is different, the compiler, the engine will treat them as a different object type because the shape of the object is different. So be careful, even though you thought you're not creating any additional new object, if you just change the order of your property, it's going to treat it as a new object. That's one tip for you, right? Okay, so there's no necessary way which one is faster than the other. All it tells you is just these two are two different object types. Okay, second thing is the internal type system. I want to actually emphasize on the throw property bags. Whenever you use throw property bags, use a container, hash map, all those things, these property bags will never be the same. When you look at these, even though you look at the code, it seems like a P1 and P2 has exactly the same code, right? But because they're throw property bags, they're little like an object or hash map, they will never be the same. For compiler, they all treat them differently. So that tells you something when you write your code. If you don't think you need all the different throw property bags, try not to do that, because otherwise you just create another copy of the object type. Okay, so this is, I think it's very useful even for me. If you have a little object like this, like a P1, and then you try to delete some of them, right, a property or something, you try to do delete, this is a very bad operation. This is probably a very expensive operation, because this is basically the delete means is making that a little bit of slot to be undefined. But there's a better way to make it undefined. You don't have to operate, this is basically a 64 bits kind of operation. So you don't need to do that, right? So instead you don't do delete, you actually just assigning p1.n equal to 0. That's the same purpose, it's undefined. All right, so this is something you want to be careful. Don't overuse delete because it's going to be very expensive. Okay, so this is something, you know, I think some people are already aware, but just in case you didn't, just because you have a little container, have like a hash map or a list, doesn't mean you could assign things like over 256 elements into it. Because if you do, it's going to slow down the performance quite a bit. What you should do is have a restricted set of properties within that particular object. In this case, it's 4 of them, but usually the compiler will take, you know, depends on the engine, right? Their threshold is usually, say, I don't know, you know, it could be like 24 or could it be a little bit bigger, because every time you allocate more property into the object, the compiler is going to create a new set of allocation for you. So it's doing in a sort of like add-on kind of fashion. So it's actually going to create a lot of unnecessary object. So be careful with your properties. Don't put like a bunch of over 200, 300 properties into one object. The other things you could avoid is, yeah, this is a pretty, I think this is a really useful one. Now, how many of you are familiar with ECMA5? Inside ECMA5, or let's say how many of us are from object-oriented programming background, Java, C#. Okay, when we do all those programming, we're very used to do the enum, used to do the get and set method, right? That's something we do. Now, with the ECMA5, there is also sort of a new feature, which is support enumeration, support get and set. So you could perfectly doing something like this. All right, and then and it's totally fine, and it's really good for maintainability and readability. Then that's true. However, if you have some mission critical paths, or if you happen to be in a loop, I have a bunch of elements there. then you should try to avoid using something as fancy as enum, because it's going to slow down your performance quite a bit. And then you could just simply assigning the property onto that. Right, just doing, say in this case is northeast, southwest. So I don't have to do the enum property, go over that, or implement again instead. Just simply doing the property signing up would be a lot faster. Okay, so let's actually take a look what we fixed in the code. So again, we go back to the code, and I do have some code which I experiment with the okay, so here I actually have the constructor for the Judy, which is a new player, and I do try two ways. One, the old way I'm trying a bunch of enums, and the new way I'm just trying the property. Let me actually show you. Oops. Player. All right. Maybe I should do the back. Okay, so I'm typing, going through all the player. I'm going to try to find that constructor. Okay, let's try this. Okay, so this is a player, the original player, which use enum, get, and set. And this is a new player which just use northeast, southwest, which will be quite a bit simple from our data. So let me go back to fix that. I'm changing to a fast player. Okay, let's do that and see if it's still working. Same thing, doing the benchmark. Okay, seems like it's still working fine. But I still seem like to see some 30s, right? Most of them 40, 50s. Okay, so getting there. Very good. Okay, so let's actually go back to see how many more stuff we could actually do. Okay, so as a result, after we change those enum to the regular property setup, the time in JavaScript execution reduced for about 30%. And then the raw performance is also improved by 30%. So that's pretty good. We're happy with the result. So again, to wrap it up, create and use the faster types as much as you can. Keep all the shape of the object consistent. Even though you change the order property, it's going to cost you. Avoid to use a mismatch of fast type. Use delete, all those things where simply you could have just assigning something to it. All right, so this is some of the tips. Okay, I'm going to go over this part pretty quickly because I'm running out of time. How many of you know in JavaScript, there is basically we're using IEEE 64-bit floating point kind of format? Know that? But how many of you basically know the difference between 31 bits and 32 bits? Okay, let's talk about that. So 31 bits meaning like integers, right? Basically, it's 31 bits data we work with. Because it's only 31 bits, so you could safely put it on the stack. Now, when you work with all the floating points, all the signed integers, all the strings, that actually push into a 32 bits operation. So because it's 32 bits, so we have to actually put it onto the heap. So people probably know the operation on stacks will be much more faster than the heap, right? So what does that tell you? Okay, so that tells me if I could have worked only with 31 bits integer, let's try it because everything will be done on stack. I don't have to even touch the heap, so performance will be quite a bit faster. Okay, so this is just give you an idea, like if I have something like this with different property, if north is integer, then I could safely leave it on stack to do more operation. And the east, the rest of them is string, floating point, OX number. All those numbers are considered 32 bits. So they could not just stay on the stack. So from stack, they have to push into the heap eventually. So in other words, if everything pushed on the heap, it will take longer to do all the operation, the manipulation. right? So this will tell you if you can stay with something like integer. So this is exactly what this example for. If you could stay with integer, like for example, I'm doing little math here, but really, if I want to work with a floating point, then I have to push it into 32 bits, which have to work on the heap. That's okay. But if my really goal is just to get an integer, I'm happy with integer operation or integer manipulation, then I should stay with integer. Then I will only need a stack to do all the manipulation. Hence, the performance will be quite a bit faster. Right? So that's just one tip for you, because a lot of times you don't care. You say dump it there, let a compiler to figure out, right? But it's probably not a good practice. Okay, so another thing is we highly recommend is if you could take advantage of what we call type specification for the arithmetics, meaning if you already know the data type you're about to work with, try to separate them into two different methods. You could work on one method all with floating points. You could have another method work with integer. That way, compiler will immediately spot, I know the data type to expect, and I could do very fast manipulation. Versus you put everything into one method, and the data could be integer or float, and the compiler needs to take time to figure out if it's an integer or if it's a float. So that way will be quite a bit slower versus if you have a dedicated method for different data type. Right? So that's another tip to share with you. So try to stay with 31-bit integer as much as possible. Avoid using float unless it's absolutely necessary to use. Arrays is actually a very interesting topic. We're going to spend a little time on that. So we have all kinds of arrays, right? But do you know if you, in your array, in the same array, if you put a different data type, you're actually going to creating all those memory allocations just because your data type is different inside of that array, right? It's from integer, float, and to string. So in this case, I have to create basically 3 types of those array allocation in order to satisfy your array because you have mixed data type. So it's always a good idea if you could pre-allocate some arrays because then the compiler will see, I need 100 elements in the array. Boom, I get it. Otherwise, it will do an incremental way, right? I increment 5 at a time, 5 at a time until it looks good. So don't use a little like what we call sort of dynamic or MPD kind of array because the compilers take much longer to operate on them. The type array is very important because this is a new feature for any of the modern JavaScript engine, for modern browsers. It is a new concept. So in addition to the traditional array, we also have the new concept called float 64 array and integer 32 array. Now, so please take advantage of the new JavaScript engine because they do have those methods optimized or those arrays optimized. So you should take advantage. If you create a floating array, use float 64 array. If you have an integer, use integer 32 array. This is a very good sort of a good use of the modern JavaScript engine. So if you have a lot of array manipulation, by all means use that. Now, some people ask me another question, say, hey, what the compiler is smart enough? You said that they're modern JavaScript compiler. They're smart, right? Could they determine by themselves if it's a float array or integer array? Yes, IE11 has a support. And I'm not quite sure the other JavaScript engine, but you could take a close look. But one thing you have to do in your code is make sure you want a compiler to recognize that array is float or integer. Make sure you put a consistent integer into that array and float into another array. Not like have a mixture, like you have OX number, float, integer all into one array. If you have some array like this, there's no way any modern JavaScript compiler will be able to determine if it's an integer array or float array. All right, so it's your code. You have to actually give the compiler easy time to take advantage of the typed array so that your code could be optimized. So this is something you probably want to watch out. Okay, don't just for the sake of easiness, right, put everything into one array. Okay, the other thing is keep the array dense. For example, you know, I don't like a delete operation overall, so try not to use delete. Always use like just assign something equal to 0 because that's going to save you quite a bit of time as well. The other thing is there's multiple ways to use enum, right? But when you do the enum kind of operation, the looping, make sure you could cache your data. For example, this is a pretty common mistake. I know this is not a really new practice, it's old practice. But in real life, people made this mistake again and again. You want to cache your length for that particular array. And then you only want to do it once before your loop. By all means, don't try to do it inside your loop, because otherwise it's going to like this, right? It's going to do again, maybe for 1 million times. And that's going to cost you. All right, so make sure you remember to do that. Okay, so best practice for arrays: use a pre-allocated array, keep array consistent. Use the type array whenever possible, but you have to make sure that array type is dense and consistent. Last piece is very simple concept, is do less with a cross-platform. So this is actually a very typical example. I know a lot of people showing it in some other performance talk, you probably see it, but it just happens every day. People still make this mistake. Okay, so this is basically how many DOM operations I have here in this first code segment. 5, right? So I have a document body, game, get element by ID, class list, and then do add and move. That's a DOM tree, right? But you're doing the 5 operations before, and it's for each rotation in our case. And then why don't you just do it, assign this, all the operation, do it once, and then you could take advantage of it for each rotation. And that would reduce the 5 operation into only 1. Okay, don't underestimate that. It's going to actually make quite a bit of difference. Okay, so the other thing is you need to remember is every time you do DOM manipulation, if you work with integers, you know any of the data from the DOM are always going to be string, right? They're never going to be integer. So why you want to waste your time to every time ask a compiler to convert it into an integer? What you can do is put at the beginning, parse integer, converting the string into an integer, and then the compiler will run quite a bit faster. In our case, we see the 25% marshalling gain. That's actually quite a bit, right? So just simply passing the string into an integer will make your life quite a bit easier, 25% gain. Okay, the other piece is, yes. So we all work with HTML5 app. We all work with animation, right? So can somebody tell me what's wrong with the set interval or set timeout animate /0? What does that 0 mean? Zero means basically it's like changing it all the time, right? It's regardless, how many, like you usually should specify a number or some milliseconds to it, right? But in this case, it's 0 milliseconds. So you change it all the time whenever you can. So normally the monitor is what? 60 hertz. And that's actually a typical, frequency for eye to catch up. So if you do anything above 60 hertz, your eyes are not going to see. Right, so why you want to waste your time to do something that human eyes could not even see? That's not going to help you with the performance, isn't it? You're doing a lot of extra work just because you set up a 0. Okay, so the right way to do is do request animation frame, and then in the set interval, set timeout, put 60 frames per second. So this is about 60 milliseconds. So every 60 milliseconds, I'm going to do the animation. So that makes more sense, right? So let's actually take a look at our code and change it. So this is the last piece I probably need to fix because it's almost end of time. So what I'm going to do is, because I said, see, this is something, it's a little trade-off. At the beginning, I said I need a benchmark to understand the known state. But when I'm at this stage, I already know in my copy bench matrix benchmark, I have to set up a known state. I have to play with a lot of CSS in order to set up the right layout. So I'm wasting a lot of resource just try to do the benchmark, right? So in real life, nobody cares about a benchmark. So what I do is I remove all the like a known state and the benchmark and leave the mass random generator to generate how should I get started with, how should I rotate. And then one piece I change is this particular timeout method. I'm actually going to comment this one out, and then by using the right method called request animation frame. This is how I do. All right, so let's save it. And let's run it. Let's see if it's still running. All right? So even though I do benchmarks, probably not going to help much. Okay, let's actually forget about the benchmark. I'll probably do it. But if you look at the data, it's improved dramatically, right? 60, almost all 60. I see something. Okay, Does that look good? Better? I don't really see the 30s, all those things anymore, right? Okay, so if you see the F12 that you are responsiveness, you will see that it's almost all reached the green bar all reached 60, has a really flat bar. And this is what we want. This would be a really ideal case. Obviously, performance test is really, in a way, it's never end. That's why I said the best way to do is actually have a performance criteria. So if you satisfy that criteria, you're good, right? So if you look at the 0 versus the 60 milliseconds, you see the performance is from 75 CPU utilization to 65 CPU utilization. Why less CPU utilization would be good, especially for modern apps? That directly relates to your battery life, isn't it? The more CPU, it takes more energy, hence using more battery. So CPU utilization is another good way to look at your apps, because it's going to save if you're going to actually have using the minimum battery life to do your application. So that's another angle to look into that. All right, so we're doing better, and then this is if you see the UI responsive, the visual throughput, you will see it's almost close to 60. No major like a big gap there. There may be some gap, it's always there, but it's close to 60. So it's for the better user experience, longer battery life, and your app will run a lot smoother. Okay, 5 principles. Now, these 5 principles are applied to the website, but it is actually the same for the modern apps, right? If people have time during a break, I could show you how I'm actually going to copy this whole app into a Windows 8 app. It's really easy. It's the same code, right? Same code base. Stay lean. That's your first principle. Use less memory. Always try to use fast objects. Avoid to use the slow, like brackets. Use the object pool, like we said before. Write fast math. Try to work with 31 bits instead of 32 bits if you can. And use fast arrays. Take advantage of the JavaScript engine's type arrays. Take advantage of that. Do less work if you can, because if human eyes is not going to see, those are good enough. Don't do it. Don't do extra work, right? Okay, so some of the resource, this you could go to Microsoft Booth to get information. You get a free shirt if you sign up for the app builder. Just drop by. Plus, we have a lot of new program for students. BitsPark startup program. Startup people, you could actually use Microsoft software free for 3 years if you qualify, right? So it's pretty easy to get. Windows 8 resource. So I have all the resources listed here. If you want to learn how to develop Windows 8 app with HTML, JavaScript, this is the resource. And also, I did a lot of HTML5, developed a lot of content, have a lot of training. So I contributed to the community, so you could actually go to download all the training class. Some of them in 1 day, some of 2 days. You could get more idea about that. I think that's about it. With that, thank you very much for attending.